All right, good morning. So I handed back the formatives, I handed back the homework from last week. If you didn't get either one of those back, that means you have to turn it in, the homework, or you have to go to the resource center and take said formative. Okay? So we got that going on. Schedule for this week, full week for all of us. My plan right now is to be here the whole week. So I'm looking at this week having a quiz, a summative quiz on Friday, and then the following Friday will be a formative quiz, and then the following Monday, so it would be Monday the 21st, is what I'm looking at for your chapter, Unit 3, whichever one you want to call it, test. Okay. So, because that week then is Thanksgiving week, and so we would only have class on Monday of that week. So that's what we're looking at right now. Not a fan. I personally am not a fan of giving a test on a Monday, but it's a necessary evil, is what the last class just described it as. That doesn't burn another week of class. Okay? So that's the plan. So using long division, let's divide these out. You should have this done by now. X plus 2 is our divisor. X cubed minus x squared plus 4x minus 10 is our dividend. So I need to get x to be x cubed, so that's going to be x squared. So here I'm going to put x squared times x plus 2, and that's going to be x cubed plus 2x. Then what I need to do is I need to change not one, but both of those signs. When I change both of those signs, then that becomes, this should be squared here, negative 3x squared. Then I drop down the plus 4x. Now I need to make x look like negative 3x squared. So that's I'm going to multiply by negative 3x. Change both of those signs. Gets me 10x. Drop down to negative 10. Now I need to get x looking like 10x, so I'm going to multiply by positive 10. Change both of those signs, and that gives me negative 30 as my remainder. So when it's all said and done, I get here x squared minus 3x plus 10 plus the fraction negative 30 over x plus 2. Agree? Okay. Now, as I told you last week, Wednesday, when we last met, that sometimes there's an easier way. And that's true. There is. This way, long division, always works, which is why we had to learn it, because it's always going to work. And the other method that we have is called synthetic division. So, because I like this guy, we're going to drop it. Oh, got the brakes. Hold on. Wrong one. Is this my
polynomial long division is
that's long division. We're not supposed to be doing long division. We're supposed to be doing We're supposed to be dropping it like it's hot. Where did my drop it like it's hot go? There's synthetic.
You guys really love that old school long division of -2. Uh-huh.
It jumped all the way.
Wow, you guys really love that old school long division of polynomials. What if you had a fancy way? Yeah, like ketchup, right? I'm talking about maybe motor oil. Synthetic motor oil? No, synthetic division. Yes. Here's our topic. Right. What do we need to do? We need to be dividing by special linear factors in order to use synthetic division. So let's talk about how we're going to get into this game. All right. Special linear factors. Yeah, something like these guys. Okay. This is not a special linear factor. Why? Because my leading coefficient of my variable is not 1. What makes a special linear factor? A special linear factor has coefficient 1 and degree 1. An example of a special linear factor is x minus 2. Okay, this is x minus c. Okay.
Okay? So that's crucial. The only time that you can use synthetic division is if your leading coefficient is 1 and your degree is 1. Okay? That's the only time. So it's very, very limited. If we were dividing by that 2x plus 2, we can't do that. We can't synthetically divide that. So we have to have that out of the way. That out of the way is long division. Okay? So that's why synthetic division is very, very limited.
Okay, what goes outside of our box? The opposite of c, or whatever's going to make our denominator 0. I'm ready for an example. Up here. Yes. Am I dividing by a special linear factor? I am. So then, okay. Zeros go outside of the box. What makes that denominator 0? -1. Zeros go on the outside. Coefficients go on the inside. Coefficients are the numbers in front of the variables. Here we go. I'm going to put a 1. I'm going to put a 3. And I'm going to put a 2. Oh. This is actually long division without the actual coefficients, and we need our special linear factors. So then what do I first do? Drop it like it's hot, drop it like it's hot. -1 times 1 gets me a -1. Very nice. 3 minus 1 is 2. Okay. -1 times 2 is a -2. Oh, and our remainder is 0. What does this mean? This means that x minus 1 is a factor of x squared plus 3x plus 2. You're going to be using something called the factor theorem to determine that. Yes, but that's neither here nor there. Where is it? Yes, we're taking 1 degree out of the numerator. It was a degree 2. So now I want to write my answer as 1 degree less than 2, which is 1. X plus 2 is going to be the quotient of those two polynomials. And then what? Yeah. And a flower. Now I'm up here. Okay. Yes. Am I dividing by a special linear factor? Yes. So what goes on the outside? Zeros go on the outside. What's a 0? Anything that makes that polynomial 0. What's going to make this polynomial 0? 1 is. Okay. And a different color. Yeah, 1 is on the outside. What goes on the inside? My coefficients. Yes. A 1 goes in there. A 2 goes in there. A -3 goes in there. And a 12 goes in there. Okay. So then I drop it like it's hot, drop it like it's hot. You know, snoo.
Yes.
Dun, dun, dun. Yeah, whatever. That was my song with one of my ex-girlfriends. Yeah, and yeah, I went away, and I'm not gonna finish that story. Anyway, she dropped me like it was hot. Oh, messed up, right? She was a horrible person. No, she wasn't. really. Yes, here's a 1. This one times that one, put it there. That's a 1. 2 and 1 is 3. Tee-hee. This one times that one, put it there. That's 3. Tee-hee. Adam. None. Yes, this one times that one, put it there. 0. Oh, Adam, and you got 12. Oh no! What does this mean? Let's go through and rewrite our quotients. Yes, I had degree 3. This is gonna take it down a notch. I wish you'd take it down a notch. Hey, whoa. So instead of degree 3, it's now gonna be degree 2. So then, this is gonna be x squared plus 3x plus, no constants, but I do have a remainder. And how do I write that? I write it remainder over divisor x minus 1. Fun. And then what? And a flower. And when I said I went away, I wasn't talking about like to the woohoo. Yeah, no, I had to go do some work somewhere else. Here we go. What makes this denominator 0? 2. Yes. So I put a 2 on the outside. And then I put the coefficients on the inside. I put a 1. Then I put a 0. Why? Because I need a placeholder for my x to the 3rd term. Yes. So 0x to the 3rd plus 0x squared minus 1x plus 2. Okay. Oh, I need placeholders. On the outside, zeros. And then on this first one, drop it like it's hot. There's a 1. 1 times 2 is 2. Very nice, Adam. 2. 2 times 2 is 4. Sure, Adam. 4. 2 times 4 is 8. Great, Adam. That's a 7. 2 times 7 is 14. Adam. That's a 16. Okay, that's my remainder. I'm dividing by a linear factor. I need to take it down a notch. This is x to the 3rd plus 2x squared plus 4x plus 7 plus remainder 16 over divisor x minus 2. Look at that one. Oh, yes. Yeah, I do think it's a hammer. Because it's hammer time? No. Because we nailed it.
Okay. This will work now. Okay. So we'll do the same warm-up problem. Okay. But this time, 1, can we use synthetic division on it? Yes. Why? So, because what we're dividing by has a coefficient of 1 and a degree of 1. So it's a special linear factor. So we need to first make that special linear factor. We set that equal to 0 and we solve it. So x equals negative 2. The negative 2 is our divisor, if you will. It's what goes on the outside. Zeros go on the outside is what he says. So 0, that's what, because we set it equal to 0, it becomes the 0. Okay? Coefficients go on the inside. Drop it like it's hot first. So the first one comes straight down, we get 1. Multiply these two, gives me negative 2. Add these two, gives me negative 3. Multiply negative 2 and negative 3, gives me positive 6. Add those two, gives me 10. Multiply 10 times negative 2. Add them, and I get negative 30. Then, because this was degree 3, and I was dividing it by a degree of 1, that means that the 3 drops down to a 2. So this is going to be my x squared term. This is going to be my x term. This is going to be my constant term, and then this is going to be my remainder term. So now that's how we get x squared minus 3x plus 10 plus negative 30 over x plus 2, which is what we had in the warm-up long division. Okay? Questions on that? All right. So, if that's my function, f of x equals x cubed minus 6x squared plus 5x plus 12, that's my function. If we plug 4 into that function, we get out 0. Okay? Prove it. F of 4 is going to be 4 cubed minus 6 times 4 squared plus 5 times 4 plus 12. 4 times 4 times 4. 64. 4 times 4. 16. 16 times 6. 96. 64 minus 96 is negative 32. 5 times 4. Negative 32 plus 20. Negative 12 plus 12. 0. So f of 4 is 0. Okay? We just proved it. Okay? So since f of 4 equals 0, that means that x equals 4 is a 0, a root, a solution, an answer, whatever you want to call it, of f of x. Okay? It's all of those things. They all mean the same thing. Zeros, roots, solutions, answers. Okay? So that's what it is. And more importantly, because x equals 4 made those roots, those zeros, those solutions, if I go back up one step in that solving process, that would mean then that x minus 4 would be equal to 0. Right? Kind of if we're working our way backwards a little bit. And that means then that x minus 4 is a factor of f of x. Because f of 4 is 0, 4 is a solution, that means that x minus 4 is a factor. Okay. With that being said, we can now use synthetic division because x minus 4 is that special linear factor, so we can use synthetic division to find the other factors. Well, we know that 4 is the 0. Let's go. We know that our coefficients are 1, negative 6, 5, and 12. Drop, multiply, add. Multiply, add, multiply, add. If it's a 0, which we proved that it was a 0, the very last number we shouldn't have a remainder. Okay? Which we don't. So what this is saying now is this is saying that f of x here can now be written as x minus 4 times, this would be my x squared term, this would be my x term, this would be my constant term. So this could be written as x, oops, wrong color, as x squared minus 2x minus 3. And if we would multiply out those two polynomials, we'd get back x cubed minus 6x squared plus 5x plus 12. Okay. What we're getting to, the reason why we're doing all of this, is I just want to say solve. Solve this polynomial, or solve this function. Find me the zeros of this function. Find me the roots of this function. And we need to do all of this in order to do that. Okay? Because now I'm going to look at that purple polynomial, and I've got two choices. Choice number one is, can I factor it? Okay? If I can, I do. If I can't, and we're solving, what can I now use? I can use the quadratic formula to solve it, to get my zeros from it. Okay? Okay? This one is factorable, so that would mean that this would factor to be x minus 4 times x minus 3 times x plus 1. And if I multiply all three of those factors together, I get my original function. I can set all of those factors equal to 0, and I can find my 3 solutions. And I know I need 3 in this one because it's got a degree of 3. Okay? So, for you eagle-eyed people that were looking at the top of the homework this week, you'll notice at the top of the homework, I've got 3 bus stops. Okay? When you're getting on the bus, has everybody ridden the city bus at some point in time in their lives? Okay? Some people haven't, but you get on the bus at a certain spot, right? And you get off the bus at a certain spot, correct? And in between there, the bus is going to be making stops. Okay? All right? Well, your bus has 3 stops on its bus route. Okay? The first stop on your bus route is you simply have to divide your 2 polynomials. That's your first stop. Okay? Now, I will tell you this. If I get on the city bus outside in the front of Wausau West High School, and I want to get downtown, I want to get off on the 400 block, okay? If I get off somewhere else, am I at the 400 block? No, right? Okay? So if I get off at John Muir, I have no idea if the city bus goes from here to John Muir or not. Okay? If I get off at John Muir, I am not at the 400 block. So I can't say that I'm at the 400 block. Okay? Right? Everybody agrees with me on that, correct? Okay? So what I'm saying is, it is your responsibility to know what the problem is asking you to get off the bus at. If it says just divide the problem, and you go all the way through and you give me the zeros, you're wrong. You got off at the wrong bus stop. You're not where you're supposed to be. If it says give me all the zeros, which is bus stop number 3, and you get off the bus at bus stop number 1, you're in the wrong spot. Okay? So it's your job to know which bus stop is. What these problems look like, these bus stop number 1 problems look like, is they're going to be some polynomial divided by some other polynomial. And you can use long division, you can use synthetic division if possible, doesn't matter to you. Or they're going to look like some polynomial on top of some other polynomial. That's still a just divide problem. Or it's going to simply state in the directions, divide these 2 polynomials. Okay? And so you just go through and you either use long division, or if you can use synthetic division, you use synthetic division, and then you're done with that kind of a problem. Okay? The next bus stop says you need to factor your polynomial completely. If this is your particular bus stop, you will be given a factor or a zero solution, an answer, a root, all those things. You'll be given one of those 2 things. Okay? At least this week. Next week, I'm just going to say, solve it. And I'm going to teach you how just you find what's what. Okay? Bus stop number 3 says, find me all of the roots, all of the solutions, all of the zeros, or all of the answers. Or it's simply going to just say, solve. Okay? Now, the nice part about this bus route is there's no express bus on it. So no matter where you get on this bus, you have to go through bus stop number 1. Then you got to go through bus stop number 2. Then you hit bus stop number 3. It's not like you get on the bus and you go right to bus stop number 3. Okay? Which means that if you have to get to bus stop number 3, that means that you will also be given a factor or 1 zero, or 1 root, or 1 solution, or 1 answer. Okay? Let's put this to work. Here we go. Given the polynomial f of x is equal to 2x cubed minus 11x squared plus 3x plus 36, and a factor of f of x. The factor is x minus 3. It says factor f of x completely. Okay? Which bus stop is this? Nope. This is the second one. It's the factor completely one. Okay? All right? So, we know that x minus 3 is a factor. So, therefore, x minus 3 equals 0 means that x equals 3. So 3 is a root, is a 0, is a solution, is an answer. All of those things. X minus 3 is the factor. Is that a special linear factor? Yay or nay? Because if it's yay, we can use synthetic division. If it's nay, we've got to use long division. Okay? So we can use it, so that means that 3 is going to go out front. Inside is going to go our coefficients, 2, negative 11, 3, and 36. Synthetic division, drop it like it's hot, 2. Here goes, or what goes here? 6. What goes here? Negative 5. What goes here? Negative 15. What goes here? Negative 12. What goes here? Negative 36. What goes here? 0. And it should be 0 because it is a factor. It was given to us in the problem that it is a factor. Okay? So bus stop number 1 says that this answer, if we were stopping at bus stop number 1, our answer would be 2x squared minus 5x minus 12 would be our answer if we were stopping at bus stop number 1. This said we needed to go to bus stop number 2, so f of x can now be written as x minus 3 times 2x squared minus 5x minus 12. Now you've got 2 questions to ask yourself. Actually, it's 1 question. So, purple, can it be factored? If the answer is yes, you've got to factor it, because it said factor completely. If the answer is no, you're done if it was bus stop number 2, which it is. Okay? So can 2x squared minus 5x minus 12 be factored? Okay, let's factor it. 2x and x. 1 and 6, 1 and 12, 2 and 6, 3 and 4 are my choices. 3 first, 4 second. 3 first, 4 second. Positive, then negative. Okay, quick check gives me these 2 is positive 3x. These 2 is negative 8x. Together, those give me my negative 5x. So f of x now, factored completely, would be quantity x minus 3 times quantity 2x plus 3 times quantity x minus 4. In any order. I honestly don't care the order. I just care that they are all there. Okay? That's bus stop number 2. If it was a bus stop number 3 problem, then we would say x minus 3 equals 0. 2x plus 3 equals 0. X minus 4 equals 0. And we'd solve those 3 to get our answers. Okay? Questions, comments, concerns, clarification? Try this.
We're doing it the same way.
Yeah, that takes like 2 seconds. Yeah. Literally make something plus substitute. So since there's you still have to make the x to the third would be.
Yeah, we were doing negative 9. I got this like.
So because 9 is a 0, that means x minus 9 is the factor, which means that 9 goes out in front there because zeros go on the outside. Coefficients go on the inside. 2, negative 10, negative 71, and negative 9. The telltale sign, the telltale thing, dropping a big hint here for you, the telltale thing is if you don't get 0 down here at the end, then you've done something wrong. Because if it's a 0, if it's a factor, you've got to end with 0 down here in synthetic division. Because that's your remainder spot. So drop, multiply, add, multiply, add, multiply, add. So this is my x squared term, my x term, my constant term, and my remainder. So f of x now can be written as x minus 9 times 2x squared plus 8x plus 1. Again, if we were at bus stop number 1, 2x squared plus 8x plus 1 would be our answer. It's what we would box. If we were at bus stop number 2, we would get to this step and we'd say, can I factor the purple parentheses? And the answer is no. So this would be our complete factored form if we were at bus stop number 2. Since this one is saying find all the other zeros, that's bus stop number 3. So then we would go on and we would say x minus 9 equals 0. So x has to be 9. That's the one that we were given already. Okay? If you write it down in the end, that's fine. If you don't, that's fine too, because this was asking for the other zeros. So if that's not factorable, then I got to use the quadratic formula. So I've got to go x equals opposite of 8 plus minus the square root of 8 squared minus 4 times a times c all over 2 times a. 8 squared is 64. 4 times 2 is 8. 64 minus 8. 56. Can the square root of 56 be simplified? To what? 4 and 14? Yeah. So then this would be negative 8 plus minus the square root of 4 is 2. The square root of 14 is the square root of 14 all over 4. With my outside numbers, they can all be divided by 2. So we have that. So these right here, this and these two are all roots, all answers, all solutions. What's the other one I'm looking up? Zeros. All zeros. The question was asking, and I would accept those. If you gave me all 3 of them as an answer here, I wouldn't take off. Okay? But the question really was just asking for the other 2. We're just asking for what the zeros are. Okay? you do have enough information now to do some of the problems on the worksheet. I don't remember if you have enough information to do them all.
Why didn't you take it?
Nope, I lied. You have enough information to do all of them.
You just stole Caleb's pencil.